So welcome students, welcome to all of you in this video lectures. Here I am continue the chapter 2. The name of the chapter is relation and function. Here I am going to discuss about the concept of relation. So students, all of you should know that what is the Cartesian product of two set. In the last video lectures I have explained about this concept, the Cartesian product of two set. The Cartesian product of two set is nothing but the multiplication of two non-empty set, and the resulting elements will be the pair of elements. I hope all of you understood. Now I am coming to the concept of relation. So the definition of relation is a relation R from a non-empty set A to a non-empty set B is the subset of Cartesian product A cross B. So students, relation R is nothing but a subset of Cartesian product of two set. Means when you do the Cartesian product of two set A cross B, and if we write a subset of A cross B, this subset will form a relation from A to B, and the elements of the relations will have a pair of elements, and from this pair of elements we can find out domain and range. So students, now I'll discuss about what is the domain, codomain and range of a relation. So it is very important. Domain, the set of all first element of the ordered pair of the relation R. So as I have told that relation R is a subset of A cross B. So A cross B is having each element having a pair of elements. One element is from the set A and other elements from the set B. Similarly, in relation R also will have pair of elements, and the first element of the relation is known as domain. So first element is known as the domain. Here it is given that suppose this is the set R, this is the relation R, and having its element A, small a capital A, small b capital B, small c capital C, small d capital D. These are the elements of a particular relation. Here the first element, small a, small b, small c, small d, are called the domain of R. So students, what is the range of R? Range of R is the second element is the range of the first element. The second element is called the range of R. Here capital A, capital B, capital C, capital D are the range of corresponding element small a, small b, small c, small d. So I hope students you understood the domain and range. Now coming, what is codomain? Codomain is the set of all second elements of relation R from a set A to a set B. Codomain is always represent the second element of the set B, or second element of all the elements of the set capital B. So students, here one example is given. I hope all of you will understand. R is a relation from A to B. So here B will be the codomain of R. Okay students. Now let us consider the set A equal to small a, b, c, d, e, and the elements of B are capital A, capital B, capital C, capital D. So students, since R is a relation from A to B, so R is a subset of A cross B. So all of you, I hope all of you know how to get A cross B. So in A cross B, we have to find out the one relation is taken R, and that relation is small a capital A, small b capital B, small c capital C, small d capital D. This is one relation is taken, one subset is taken from this Cartesian product A cross B. So when you do A cross B, you will get all the elements, and more than that, because you have to do A capital A, small a capital B, small a capital C, small a capital D, like this with B, C, D and E. So here R is a subset of that A cross B whose elements are listed here. In this set R, domain is the first element, as I have already discussed. Range will be the capital A, B, C, D, and codomain will be the set B. So students, I hope all of you understood what is the basic concept of relation and how to get its domain, range and codomain. So students, I repeat once again, relation R is a subset of Cartesian product of two sets. The elements of a relation is nothing but a pair of elements, and the first element is called domain of the relation R. Second elements are called range, and the set B here, set B is the codomain of range, codomain of the relation R. So students, I'll go to the next topic. Sorry, the next one more example here is taken. Let us consider two set A equal to 1, 2, 3 and B equal to A comma B. Now all of you know how to get A cross B. 1A, 1B, 2A, 2B, 3A, 3B. Now let us consider one relation F1 from A to B. So when you take a relation F1 from A to B, F1 must be a subset of A cross B. Suppose F1 is taken 1A, 3A, 3B. So since all the elements lies in A cross B, so F1 must be a relation from A to B. And here the domain of F1 will be 1, 3 and 3. So only 1 and 3 you can say. And range of F1 will be A and B. So students, what is the codomain of F1? Codomain of F1 will be the set B. All the elements of set B means A comma B. One more relation is taken F2 and its elements are 1B, 2A, 2B. So F2 is also a relation. So such that similarly we can form many relations of the relation from the set A to B. And the number of relations will be the same as the number of subsets formed from the set A cross B. And we know that this is nothing but the power set. So what is the definition of power set? Power set means the possible number of subsets that can be formed from a particular set is called power set. So the total number of subsets that can be formed from the A cross B will be the number of relations formed from A to B. And this is nothing but the number of power set. And we know that the number of power set will be 2 to the power n. N is the number of elements. So 2 to the power here number of elements in A cross B, number of elements are 1, 2, 3, 4, 5, 6. 2 to the power 6, it is 64. So 64 such relations is possible from A to B. And these are, so I hope all of you understood this concept. There are some points to be noted. A relation may be represented algebraically either by roster method or by set builder method. An arrow diagram or a visual representation of a relation. So an arrow diagram is possible to represent a relation between from a set A to a set B. So here one example is taken. Let us consider A be a set whose elements are 1, 2, 3, 4, 5, 6. A relation R from A to A is defined as this relation is given in set builder form. Okay, and this relation is formed from A to A. So R is a subset of A cross A, and whose definition is given x comma y, y equal to x plus 1. So students, x and y both are the elements of A. So this set we can write in roster form like this. When you put x equal to 1, the value of y will be 2. When you put x equal to 2, the value of y will be 3. When you put x equal to 3, the value of y will be 4. When you put x equal to 4, the value of y will be 5. And when you put x equal to 5, the value of y will be 6. So when you put x equal to 6, the value will be 7. This is not possible because 7 is not there in the set A. So these are the elements of the relation R which are in roster method of this relation. And this relation we can represent in arrow diagram like this. 1 is related to 2. So 1 is related to 2. 2 is related to 3. 3 is related to 4. 4 is related to 5. 5 is related to 6. Like this arrow diagram, we can represent a relation. Now students, what is domain, codomain and range of this relation R? So domain, as I have told, the first element is called domain. So 1, 2, 3, 4, 5 is domain. And ranges are the second element, 2, 3, 4, 5, 6. And codomain is the set A. A to A, the second set is codomain. So 1, 2, 3, 4, 5, 6. So students, I hope all of you understood this question. Next question is A be a set having elements 1 to 14 and define a set R. So define a relation R from a set A to A. And relation set R is given like this. The definition is x such that 3x minus y equal to 0. So we have to find out its domain, codomain and range. So students, as R is a relation from A to A, so R is a subset of A cross A. So we have to find out A cross A first. Okay. So A cross A will be 1 to 14 in the first set A and into 1 to 14. So its elements will be like this: 1, 1, 1, 2 up to 1, 14. So 1 is over. Then with 2, 2, 1, 2, 2, 2, 14. Similarly, the system will go on. Lastly, 14, 1, 14, 2, 14, 4. These are all the elements of A cross A. Now, we have to consider this given relation. Its definition is given like this. In roster form, 3x minus y equal to 0, x and y belongs to A. So, we can write 3x equal to y. So, these elements will be when x equal to 1, when x equal to 1, y equal to 3, when x equal to 2, y equal to 6, when x equal to 3, y equal to 9, when x equal to 4, y equal to 12, when x equal to 5, y is 15. 15 is not present, so we have to stop here. So these 4 elements are present in the relation set R. Now from this you can easily find out the domain. Domain are the first element 1, 2, 3, 4 and range the second element 3, 6, 9, 12 and the codomain will be the set, second set, this A. So students, I hope all of you understood. Now there is another question. Write the relation R x comma x cube, x is the prime number less than 10 in roster form. So students, the relation set is given x comma x cube, x is a prime number less than 10. So prime number less than 10, we know that 2, 3, 5, 7. So when you put 2 in the first element, the second element will be 8. When it is 3, the second element 27. When it is 5, it is 125. When it is 7, it will be 343. Here is one more question. Let R be the relation on Z defined by AB such that AB belongs to Z, and its definition is A minus B is an integer. Find its domain and range. So students, when a relation is given on a particular set, it is given on Z. That means R is a relation from Z to Z. There is R is subset of Z cross Z. The Z is integer, so Z cross Z will be formed like this. And when we present this given set, A minus B is an integer. The definition is AB, A minus B is an integer. So students, we know that the difference between any two integer is always an integer, right? So domain of R will be also an integer. Each element will be an integer. So domain of R will be Z. Similarly, range of R will also be a Z. So I hope all of you understood. So students, here I am ending my today's video lectures. Here I have explained the concept of relation and how to find its domain, range and codomain. So students, here are some questions I am giving to all of you, and if you have any questions, any doubt, you can contact me. Thank you very much.